Okay, so what's up guys? Welcome back to a brand new academic learning video. In this video, I'm just gonna be doing a short little video on why I think pi is cool. Okay, so today is March 14th, 314, which are the first three digits of pi. 3.1415926535897 79, blah blah blah. And this basically goes on forever. And pi is an irrational number, meaning it cannot be expressed as the ratio of two integers. And the reason that's so special is because, well, pi has been known for a long time, right? The ancient civilizations like India, Greece, they made connections between a circle's diameter, or the line that's like this, and the circle's circumference like this. And what they realized is that for all circles, the ratio of the circumference of the diameter is the same. And that's pretty cool because that means that if I scale up the circle by 2, I know that the ratio of the circumference and the diameter are always going to be the same. And this ratio just is pi, as you might have guessed. And the reason why this is so special is because it's not just circles. Most people just know about circles, but pi comes up everywhere, and that's what makes pi so special, along with the other constant that shows up everywhere, e. But fortunately, there is no e day. Maybe that should be a thing. That would be February 71st, though, so maybe that shouldn't be a thing. But anyway, so let's look at some other applications of pi. So first, circles. That was the first to be discovered, the ratio of the diameter to the circumference. But also, if we're talking about area and we know the radius of the circle, then we know the area. That's just pi r squared, as many of you probably know. But that's so special because the connection between the circumference and diameter, this is just circumference and diameter, that shows up in area. Area is a squared quantity, meaning it's something like centimeters squared. But circumference and stuff and diameter, those are just centimeter or regular quantities to the first power. So it shows up in higher powers, and surely that has to be some indication of something special. And let's go beyond circles to spheres. I cannot draw a sphere. Sorry, that probably looks nothing like a sphere, but just pretend. And a sphere also has a radius. It's the set of all points equidistant from the radius in three-dimensional space. And guess what? Both the area and surface area of a sphere are expressed in terms of pi. Surface area, 4 pi r squared, and area is going to be 4/3 pi r cubed. Okay, so now people were like, pi just deals with round objects. I mean, if you have a cylinder, the area and surface area of this is also using pi, so maybe just pi is a round object thing. But no, pi comes up everywhere and not just round objects. For example, there's this famous function, e to the negative x squared. And why is this function so famous? Well, if we graph it, if you have 0, e to the 0, 1. And if we go to the right, we'll get e to the negative power. So that's going to be close to 0. To the left, e to the negative power squared becomes e to the negative positive, or like if you have e to the negative infinity squared, that's going to be e to the negative infinity squared becomes positive infinity, and that just approaches 0. By infinity, I'm just subbing that in for like a relatively big number, so you can see what the behavior of this graph is like. So it's something like this. And what's so special about this graph is this bulge in the center. Now think about it. What daily phenomenon has the highest occurrence at the center? Well, that's just going to be everything, right? If we think of test scores, the median, or the middle, is going to be the highest occurring phenomenon. And as you go out to the lower ends and higher ends of the spectrum, it's going to happen less and less often. So this graph is really nice if we want to express probability. But one thing that has to happen in probability is, let's say this graph represents the probability of someone having a score rep by what score they have. So let's say if they got a score of 0, they'd have a probability of 50%. And if they had a score of 50, maybe have the probability of 1%. Negative 50, maybe also 1%, and so on. But the probability has to sum to 1, Why does the probability have to sum to 1? Well, because it has to have some probability of being somewhere. So the probability, so what that basically means is that if we take the area under the curve of this graph, that needs to be equal to 1. Not going to explain too fully about that because I want to get into the calculus here, but just a brief intuition. So this little squiggly things means area under the curve. Again, I don't want to get too into the calculus here, but if the area under the curve from the entire graph, so negative infinity to positive infinity, if that's equal to 1, then what does this have to equal to? Well, whatever this area is, let's say the area is 2, then we can just introduce a constant of 1/2 into this equation. That's going to scale everything down by a factor of 1/2. So this area will become 2 times 1/2 or 1. So first, we need to find the area of this alone, and then we can multiply it by the reciprocal of that area to scale the area down to 1. So what is the area of this graph? It's the square root of pi. What? How does that show up? And there's an excellent video by 3Blue1Brown to explain why that shows up. But just think about it. The circle thing that ancient mathematicians have thought were just for circles comes up in statistics. And this isn't the only unusual place where pi comes up. Pi comes up everywhere, just like e, which is another constant that I think doesn't get as much praise as it deserves. Okay, so that's just going to be a quick little rant video about why I think pi is one of the best constants in mathematics. And yeah, if you're watching this on Pi Day, happy Pi Day, and I'll see you in the next video.